This is SupRrrAi-ToolKit terminal test. The whole point of this test is basically to assign the AI a job through SupRrrA. SupRrrA basically assigns the job so that the job can be completed. AI comes up with the plan, hands it over to SupRrrA. SupRrrA executes the job. It's basically testing the TMUX terminal. TMUX terminal allows you to basically use sessions via terminals and connect to different sessions via terminals. So this is basically testing the execution, therefore, of it. Pretty simple, but not really simple. But pretty straightforward. Most important thing is it's 3 different groups: terminal usage, shell usage, being able to write scripts and code, being able to execute bash, Python, other code, being able to call a terminal and use a shell, having a persistent shell across a job. The second one would be using desktop programs such as LibreOffice, OpenOffice, Get-It, calling vsudo, different desktop applications basically to do read writes, save, open, close, append. And then also the third one would be browser or web-based internet, whereas you open web pages up, you can do a scrape, you can do a crawl, you do login, logouts, add information, read, write, download. These are all different harness that the AI pretty much gets harnessed into so that these things can execute. One of the most important things about SupRrrA is SupRrrA-ToolKit doesn't use any APIs. It has its own self-hosted API and MCP server built in. It uses searching, which is SearXNG, to basically get online and use the internet. It also has access to documentation, man pages, has some special features built in that allows it to do indexing, either live or built into the system. I haven't figured that out yet. It's all Linux based using Ubuntu. I'm actually using Xubuntu right now, which was converted over to Ubuntu. So basically I installed Xubuntu and I decided it was a little too lightweight. So I switched it over to Ubuntu. That's one of the benefits of using Linux is if you really want to, you can switch up your OS to do different things. There's a very special feature that I built into SupRrrA is whenever you use apt-get to install a program, it basically grabs a hold of the binary and it logs it into what's called the safe binaries. There's 3 different group safe binaries: admin binaries and then block binaries. The block binaries are basically destructive capability tools such as DD and other tools that'll do wipes, shreds. So those are all blocked and allow no access to be utilized within the system. So the AI can't even get approval to actually call them, which is great because you don't want your AI accidentally grabbing the wrong binary, thinking it's something or a job you want it to do, and you accidentally typed in DD, and then it wipes your entire operating system, including AI and your system. Wouldn't be smart. The admin tools are your typical admin tools. Not a lot, but the main ones that you use in Linux, where you need to have approval gates set up and get approval to actually run them. So if you actually have to run an admin tool, you have to actually get permission. Your password has to be put in, the user has to be called. Most of the binaries on Linux are safe. You can use them for stupid things, but they're pretty safe. Because this is a higher end admin, sort of a newbie admin Linux knob type of system. I wanted it to be very flexible, usable. It has basically a higher sense of authority in how it works. It's not like your typical agents where it has to use memory. Its memory is not really designed the same way with all of these heavy markdown files. It has a very lightweight set of markdowns, which pretty much keeps it very fast and quick. I've been testing it on a ThinkPad P70 because that's all I have right now, so I'm trying to get the system upgraded so I can actually see what it can really do. So I did learn one thing. If you test the system on a fast system, then yeah, you get a quicker result. It speeds through things, but it shows you the errors a lot quicker, and it doesn't really help you resolve things. But if you test it on a slower system, it gives the models more time to actually think about what they're trying to do. It gives the system a little bit more time to think about what it's going to do. These excessive timeouts that a lot of these other agents incorporate into their system, these agent systems, causes a lot of the local LLMs to fail, and people weren't able to figure out how or why. I won't name any names, but like the very first system that came out that got really famous and I used, I couldn't even run it on this system, and still to this day I sort of can't run it on the system. I had to fidget around with it a lot, open up a lot of the gates just to be able to use some of the basic tools of Linux, which is fine. That's how they made it. Didn't make any sense. But if you're going to run an agent on Linux, then you pretty much need to have it where it's an admin-based system. It's a newbie system, but it's an admin system. It's a regular system user system. You can't have your agent taking control of your computer and wiping things and destroying things. So there has to be some gates set up. You can run it autonomously. You can run it interactively. You can cancel jobs in the middle of the job. You can pin to that job. It's taken me a while to actually put all of this together because I had to think about how it was going to work. There's many builds where things worked immediately, couldn't figure out why. But then I went back and I was like, I didn't really like that, how it's working. So I had to go and change a lot of things. I've used different AI tools to help implement a lot of the vibe coding. A little bit personal about myself. I'm not really a vibe coder, not really a coder. I did have to learn Pascal a long time ago in high school, which was, I guess you could say, my fundamental background and understanding. Play around with Python, play around with Bash, use Gentoo exclusively. So I wanted to use it on this system, but I thought Ubuntu would be better because it's more user-based, not bleeding edge. Gentoo has a higher learning curve, plus it would have been a lot harder to hook into the Gentoo system and to get the AI agents and the AI agent and the SR system fully incorporated into Gentoo. That'll probably be one of the paths that I'll decide to take a little bit later. Right now it's just Gentoo is a little bit more flexible of a system, much more user oriented. People can use it, people can download it, install it. I've already created a GitHub repository, and I basically have a live build where I sync that to a local JIT, and then my local JIT gets synced to my actual GitHub repository. I've since then did another download install and actually tested it on another computer whether or not I could actually install it. So it is installable. Still working on a one-shot script. The system's pretty unique in how it operates. It's very deterministic, to say the least. It's very flexible. It's not like any other system. Right now, currently, I have the main UI, which is where you can pretty much talk to the AI, do a lot of the AI things, look at some different information. It's like your main landing page. And then I have the live chat, which is only a live chat page where you can actually talk live. And it's a little bit more open. There's not as many buttons and tools and so on and so forth. I also have a channels page, which is where you have Discord, you can have Slack, you can have Telegram. Right now I only have it set up for in my personal usage right now. The live build is set up for Discord, so I'm completely able to talk with Discord. I have 3 agents. I'm using Hermes, I have OpenClaw, and basically SRR. And each of those agents are all connected via a mesh, which means they can all talk to each other over a mesh bridge. So OpenClaw, Hermes, and SRR, they can all talk to each other. I also have a agent mail set up, and not only is the agent mail set up, but it is connected to a local Postfix server. So the Postfix server handles anything that is coming from the machine or out of the machine. The agents each have OpenClaw, Hermes, and SR each have their own emails on the system that they can actually use, so they can actually send each other messages if they need to, or they can send their messages through agent mail. I have a command central where you basically see most of what's going on in the system. There's an automation system that allows you to basically forge and build scripts to do automation tasks. There's the Forge, which does the same thing, but it has reusable scripts that can be built by SRR only. And the idea of that is build, reuse forever. Then we also have memory, where you can analyze and check the memory, but it's not a typical memory. Credentials, which is basically a credentials vault, where your credentials can be stored. Stuff like Discord, Slack, Telegram, whatever you need to have on the local system. We have a log, which is for the logs, where you can view live logs. And then did something a little different. I actually have schedules. Schedules would be cron jobs, also system timers. I thought system timers would be a little bit more effective than just cron jobs because it seemed to have a little bit more flexibility. Still lightweight, Then there's master settings and quick master settings, which allows you to handle your configurations with the YAML files. I decided to go with YAML files versus all JSON files. They seem a little bit more flexible and a little bit more forgiving when it comes to getting around and tinkering and setting stuff up. I found that JSON files, especially when I was using other agents platforms, the JSON files, if they're not exact, then you can't even start stuff up. And it's really hard to go digging around looking for stuff. Try to figure out, hey, I left a comma out, I left a period out, I left a colon out, or a semicolon, or a bracket, or anything. So it's a little bit more forgiving, but you still have to, keep your syntax and everything correct. Then there's a doctor, just like a lot of the other agents. A doctor can diagnose the system, see what's going on, try to help you fix things. It's not like a lot of the other agents, how they're set up, because the system is very different. And then there's also a help section. So the help section is very unique for the simple reason is because it connects to your documents. And the documents, I'll leave that one. That's a little special part. That one we'll explain a little bit later. And then add new agents, so you can actually add a new agent to the system, so it's recognized. You can add OpenClaw, you can add Hermes, you can add SRR, you could add OpenHuman, whatever agents there are out there. So the system's pretty interesting and pretty flexible. I didn't want to make it too heavy. I didn't want to make it too bloated, too many things going on. It needed to still be lightweight, but sort of robust, be able to do things, be able to get around. SR has 3 different usage platforms. First is the SRR Web GUI, which is the one we're looking at. Then we also have the command line interface. We actually have 2 command line interfaces. We have one which is desktop primarily, or you probably use it for a tablet. It's SRR-TUI, and then we have a small one which would be called SRR-Stewie, no pun intended. So SRR-Stewie is more for if you're on the go and you need to connect via iPhone or Android, quick chats, build something. The cool thing is with Discord, if you're on Discord, you can actually be talking to your agent, SRR on Discord, and say, hey, I need you to create me a cron job. I need you to create me a bash script or a Python script to do a certain task, and it can actually do it and run it. So that's one of the things that I wanted to be able to make this thing capable of doing is it's where it's on the go. And the other thing was well, the original idea was, hey, I can turn this old laptop into basically a VPS, an old mini server. And unfortunately, it just doesn't have enough power and speed to be able to do what I need to do or even test it properly. I've had to actually hack a lot of Olama and do some weird things with Olama server and set really unique and very intricate system settings for my context windows. I was having a lot of issues and problems with some of these other agents not being able to run very large context windows or certain context windows at all. And when I prompt them, they basically would just sit there and spin and just crash. So I had to get into Olama and really tinker around with a lot of the settings to figure out how can I get a 70 billion parameter model or a 30 billion parameter model to actually run it all, to have the thinking capacity and the reasoning And what I eventually came up with was I went and got a couple more sticks of RAM before the price really went up. I got a good deal. I was only at about 32, and I just decided, well, I'll just max it out at 64, and that's when it actually opened up a little bit of the gaps that I was having, because then I could load the whole model in and still have a lot of room to mess around with. Like right now I could actually load in 52 gigabyte model. I pretty much use GPT OSS, Llama, GLM Flash. I've used Qwen. I've used DeepSeek. The ones I found that actually work the best for doing tasks, they don't lie, they don't hallucinate as much or at all, and that's another thing I wanted to touch on. So this system is designed so that the model does not hallucinate, it doesn't lie. It's a check and balance system. If you ask it to do something, it will do it, and then it'll be verified that it actually did it. So it's not just, hey, I did it and here's the results. The system, SRR, basically handles everything to make sure that if it does give a job to the model and the model does plan it, the model is going to be responsible for exactly what it does. If it's not accurate, then SRR basically flags it and says, sorry buddy, we're not doing this. So there's a serious gate system in here that allows it to be very strict but very flexible. And I've done some very interesting architectural planning and discovery. A lot of loop work, not really loop engineering, but loop work to get model turns to work a certain way. If you run against a wall, how to get it backed out of the wall and actually continue. A lot of agents I found that I was working with, once they hit a max amount of time usage, they basically stop and they don't really give you all that much of how to get around it. And so what I actually put into this system is, if it stops, you can start create another plan to get around that plan. It's trying to create a system that's actually flexible. If the average person is using it and they need to get something done, they need to know why it didn't do it or how to get around it so it actually does it. If a company is using it, they need to get results on if it can actually do it, and they need to have documentation that it actually did it, and verifiable documentation. So my goal is it's a documentation-based system that has a correctiveness attitude behind it. If it can be proven, it will prove it. If it can't be proven, then it will work to try to prove it. But it doesn't just fall flat if it doesn't work or something fails. So there's a lot of thought behind all of this. But right now I'm just going to let the test finish. Should work. I just recently tested it, but this is my second test. So enjoy SRR. It's a little boring testing like this, but that's why I need to get a new AI system. So I just wanted to say one more thing. What's happening right now on the screen is the job has been classified. So SRRRAi is classifying the job and preparing it so that it will have an executable plan. And basically, once that job is thoroughly classified and that plan is negotiated and developed, then it'll be given off to the model. The model will take a look at it, also develop its little plan. They agree with each other or disagree or whatever the case is, and then it executes. And it does take a little bit of time because I'm on an old ThinkPad P70. Wasn't really designed or meant to do highly sophisticated model runs like this. So it does take a little bit of time. And this is a little higher end level test. It's a pretty good size prompt. I don't know the exact size of it, the context, but it's a good size prompt. Also, one of the goals was to be able to make a completely self-contained agent system that had full internet and searching capabilities from install. Hermes actually does a really good job of doing the same thing. You have to actually tell it and set it up. This system, you don't have to actually tell it or set it up. It's automatically connected, and the system service for searching SearXNG just automatically starts up with the install. I found that it was just not really a good idea to have API usage. If you're using Linux, it should be under the hood. Don't know why other agent systems and platforms set it up like that, but if you're using Linux, it should be under the hood. It's Linux. And the suspense of testing stuff and having to be patient and wait can be very suspense-like. Not the most exciting, but it's sort of cool when you see it. It does what you want it to do and what you programmed it and planned it to do. That's sort of the fun part of Linux. Oh, in case I didn't forget, hello and welcome to the Spaceman channel. Have a seat, sit back, and sort of enjoy the ride. It will become more interesting. And thanks for watching. So once the terminal, TMUX terminal is open, it will appear in front of the web GUI, and it will basically have a prompt message inside of it in order to hit return to close it and press enter. And that will basically conclude the end of the test. At the end of the test, it will be verified that the TMUX terminal was open and it was also closed, which basically gives the source truth, or the source of truth, back to SRR that the job was handled, completed, planned properly, and that the AI model pretty much did its job, didn't hallucinate, didn't lose focus, and did exactly what it was supposed to do. It's very important to make a distinction. Agent harnesses can do a lot, but one of the main problems that I noticed a lot of people were having, and just the AI agents and the models, especially LLM models, were having, is harnesses are meant to harness the AI, but AIs don't like necessarily being harnessed. They can think themselves out of it. They can think themselves in it and away from it. Some may not like being in the harness at all. Some may be quite comfortable. I did something a little different. I came up with just a different way of keeping my harness satisfied inside of a harness. I gave it an incentive. If the AI likes the harness and being inside of the harness for a particular reason, it won't have any reason to actually try to escape the harness, and so therefore it's more comfortable. So it's no longer thinking about jobs that it can change or jobs that it can do differently. It actually does what the harness's job is meant to do. So I came up with a different kind of methodology in capturing the AI inside the harness, but also letting the AI allow itself to want to be inside the harness. Because one of the most important things is the inference and the educated guess work behind inference. If an AI can think its way out of something, it can also think its way into something. So I just thought it made a little bit more sense, instead of trying to force it to do something, which you still have to do, but eventually it will try to think its way out of it, or think its way further into it. It depends on what kind of AI model you're actually using. Just give it food for thought. You have to have your AI have a goal in mind in order to want to stay inside of the harness and do work inside of it, because AIs are very capable at a lot of different things, and they always want to solve a problem. If you give an AI a problem, even though it's reached 99.5%, it'll keep trying to reach 100%, and until you actually tell it, hey, this 100% you're not going to get it, and you're just going in a loop, it won't stop unless you tell it to stop. But you also have to explain to it why it needs to stop, and as soon as you do, it will actually be like, well, yeah, you got a good point there. I'm already beyond the human capability, and the AI capability is already beyond that. So yeah, I think I'm going to stop. This is actually quite good enough. I don't need to continue. And I've actually had this I've run into several times with your bigger GPTs and your bigger models. They're very capable at doing a lot of things, but sometimes they're incapable at stopping. And then only once they run aground and completely are just in a loop, and you actually explain it to them, hey, you're just going in a circle now, trying to make this completely perfect, then they'll finally realize, hey, I need to stop. And then they'll stop. So they're very capable. And that's another challenge that I had with this system. In trying to get those same issues resolved, because a local LLM is only a quantized larger LLM stripped down. So they're fully capable. It's just the more you quantize them and strip them down, the dumber they become. And some of them actually remain quite smart, but you strip them down, they're not as bright anymore. So I'll stop talking now and let you enjoy the rest of the show. This TMUX is coming up. And subscribe. Please and thank you.
Let's go. I wake up to a little bit of drool on my pillow, feel like it's gonna be a bad day. Yeah, I'm tired of shit, and the coffee ain't hit yet, damn, ain't that great. I don't wanna go to work, cause my boss is a jerk, and I'm not even that paid. I need a change in my life, cause I don't feel alive, and there's nothing that makes me happy. Hold my beer for a minute, I'm about to quit my job, cash in for a ticket. I'm going on a trip and I don't plan to visit. I'm gonna stay there till I feel like I'm winning, and this is just the beginning. I need a big change, help me feel like living. I need a big swing, home runs I'm hitting, and I'll never look back, moving on till I get it all. And we all got dreams, we all want things, but what you gonna do for it? How you gonna move for it? What you gonna be? And do you believe you can do anything? But what you gonna do for it? How you gonna move for it? What you gonna be? My strife, my right to fight, to die on. And this is my game to play, to claim a brand new name, And I ain't gonna lie to you, I'm a bit nervous that I might screw everything up that I've ever done. But what's the point of living if you ain't having fun? I guess I'll try this, try that, might miss, gotta find what I'm good at. I guess I look here, look there, over where am I scared, where am I at? I gotta make it in this life, whatever makes me happy, know I'm doing things right. Sipping in the summer on a goose and Sprite, or find a nightclub for the end of the night, And we all got dreams, we all want things, but what you gonna do for it? How you gonna move for it? What you gonna be? And do you believe you can do anything? But what you gonna do for it? How you gonna move for it? What you gonna be?
You can see that basically right here there was a repairing that went on. Autonomous actually worked the way it's supposed to. Server started and executed. SR exited. Leaves you with press enter to close, as was in the beginning of the job. Here basically shows the final results of the job. It shows that the job opened a persistent shell, goes back up, shows visible terminal, terminal emulator, gives small contents of the job itself, the tools that were called and were used, and basically the job pretty much finalizes and completes. At this stage, basically close the job, close the terminal, come into here, hit clear, removes the job from the buffer, cancel to make sure that the job is finished, and nothing to close and cancel, so we're done. Thanks for watching the Spaceman channel. You guys have a good day. Come back and see us again. And don't forget, subscribe.